In this video, we are going to see the first come first serve scheduling algorithm in OS. We can abbreviate this first come first serve scheduling as FCFS algorithm. In this, the process will arrive first, which arrives first will be executed first by the CPU. It is a non-preemptive type of scheduling. In this, the priority of process does not matter, or you can say whatever the priority of the process will be executed based on their arrival time. For example, we can consider four processes with their arrival time and burst time. We can name the processes as P1, P2, P3 and P4. They arrive in the order P1, P2, P3, P4 based on their arrival time, and the burst time is the time required by the process to complete its execution. This is given in this table. For these four processes, a graphical representation of the scheduling can be given by a Gantt chart. This we can serve the process in the first come first serve order using this Gantt chart. In this, we can see the process P1 arrives at 0 milliseconds and its burst time is 5, so it completes within 5 milliseconds. At that time, meanwhile, the process P2 has arrived in the ready queue because it arrives at the third millisecond while the process P1 is executing. So we can say P1 arrives at 0 milliseconds and P1 does not have to wait, so its waiting time is 0 and it is allotted the CPU first. And then P1 requires 5 milliseconds to execute. Meanwhile, process P2 has arrived in the queue, ready queue, but P2 has to wait till P1 is completely executed. Because of this non-preemptive nature of FCFS, the waiting time of P2 will be P1's burst time minus the P2's arrival time. That is 2 milliseconds, because the P2 has arrived at the third millisecond and the burst time of P1 is 5. So 5 minus 3 is equal to 2 milliseconds. This is the working of the arrival time of P1 and P2. Then we can see P3 and P4. While P2 is performing its execution, because P2 has its burst time of 24 milliseconds, that time the process P2, P3 and P4 arrive in the ready queue. Process P3 get a chance of to execute at the only at the 29th millisecond, where the waiting time of P3 is equal to 24 milliseconds because it arrives at the 5th millisecond when the process P1 completes. So its waiting time will be 24 milliseconds and it requires 3 milliseconds to execute. And then while P4 get the CPU at 32nd millisecond, the waiting time of P4 will be 24 milliseconds and it requires 20 milliseconds to complete its execution. This is the total working of the waiting time of process P1, P2, P3 and P4. There are various other measures that are used to assess a scheduling algorithm. They are throughput, response time, turnaround time, and we can calculate these measures also. We can calculate the response time, like the response time will be the time spent in the ready queue to get the CPU for the first time. For P1, it will be the response time will be 0. Since it is the first process, it will get at the 0th millisecond. And for P2, when P1 completes its burst time of 5 millisecond, then only the P2 will get. So it will get at the 5th millisecond. And for P3 it is 29th millisecond, and for P4 it is 32nd millisecond, that we can see it from the Gantt chart. And for turnaround time calculation, for it is the completion time minus the arrival time. The completion time we can get it from the Gantt chart, that is for P1 it is 5 minus the arrival time. Arrival time is it is 0, so 5 minus 0 is 5. Then for P2, its completion time is 29, and so its arrival time is 3, so 29 minus 3 is 26. And then for P3 it is 32. 32 minus its arrival time is 35, that is 27. Then for P4 its completion time is 50. 50 minus its arrival time is 8, so 50 minus 8, 42. So we have calculated the turnaround time. Then the throughput is number of processes by time. It's 4 processed by 50th millisecond only. It's completing all the 4 processes. So 4 by 50. You can say the average waiting time will be 12.5. Then we can move to the advantages and its disadvantages of FCFS. Advantages, it is easy to implement and it's easy to understand, but disadvantages is when a process with less priority being executed by the CPU, and if a high priority reaches the CPU for execution, the CPU does not take this high priority process for execution, so this process has to wait because of this non-preemptive approach of scheduling. So and also the average waiting time is high, and the average waiting time is not optimal. There is no possibility of parallel utilization of resources. Subscribe to my channel if you feel contented.